So welcome everybody. This is a Q&A interactive session. Today, clearing the doubts of the past questions of the DGD and clearing the concept. So the first question asked by Billy, right? He asked the
Yeah.
question, why do we have to do the integral in this question? How do we figure out that when do we have to do the integral? Am I correct, Billy?
Yeah.
So as you see, the trick in physics or anywhere, everything is hidden in the question itself. The question says that this is a uniformly charged rod of length. That means every point is a at this is a rod and every infinitesimal point has a charge. In order to find the effect of whole rod, that is a finite length. That's why the Gauss law cannot be used here. We use integral to find the effect of every infinitesimal point. So again, to give you the concept of integrals, there's something called discrete variables. That means you have a collection of point charges. They are not continuous. They are separated by some distance, and they're free systems in itself. This is the point to be emphasized is they are the free system in itself. Then you can't use integral. You use summation of charges, ui. Let me write it proper. This is a summation. If you have to find the electric field of all, you sum it. I believe you read this in your lecture. And for the and if you have some figure surface like this, an irregular surface, but you have a uniformly charged, that means every infinitesimal point, that means a smallest dot has some charge related to it, and then you have to find the effect of whole surface at point P, then you do the integrals. That is, in this case we use Gauss law if it's a regular surface. This is the divergence theorem, not the Gauss law. I'm very sorry. Divergence theorem. But the point to be emphasized is not divergence theorem, is that we use integral. Integral says it takes care of every point. That's why we use integral. So how did I get it? I get it from the point when it says it's a uniformly charged rod L and I have to find the electric field at point P due to whole rod. Everybody's with me on this? Perfect. Perfect. Thank you very much. Okay, Billy, go ahead with your second out. Query
So
or
the
question?
second question I had was I was trying to redo this question, and I wasn't clear on how you solve the integral itself.
Okay, which part you have to point me out here?
Yeah. So I think it's so where you have ex and ey, so like the components.
This point
Yeah.
here.
Yeah.
So you got it before it, right? That Ex is dE sine theta, Ey is dE cos theta.
Yeah.
Okay. And you know the sine theta and cos theta how I wrote it.
Or sorry.
You got it how I wrote sine theta and cos theta in terms of distance.
Yes.
Okay, you get it.
I
So this
understand
is
that part. I don't know if other people are also confused on this, so I don't want to speak for them, but
no, I assume they get it. Otherwise they would have like opened their mic or they must have like had something in the chat box, right? Like about it. So I assume they get it. So I'll address particularly your doubt. Okay.
yeah.
So after this point, I substituted for sine theta here and I substituted for dE from here, right? dE is just Coulomb's law
Yeah.
and sine theta I did put it here. Now afterwards, this is an integral by substitution. I use d square plus x square as u, then 2x dx is du. Then I put it here, and then I did the integral afterwards. Then I substituted it back, and I used the limits from x going from 0 to L. And now you have to point again which point you're not sure again.
I'm just looking back at my notes 1 second.
For sure. Anybody can jump in if you're not getting any point. Like, yeah, feel free to do that.
The sorry, can we backtrack to where you got the EX part? I think that's where I messed up some of my calculations.
Here,
One up.
here.
Like E, sorry, yeah, right there.
Okay,
I
okay.
think
You
that's
see
where I
this?
miss.
It's okay. It's okay. It's a fair point. Here, you see this is a dx element in the drawing,
Yeah.
whatever we call it, drawing. So yeah. So it's a mess. So this is a dx element. Now at the point P, you have two components, ex, sorry, ey and ex, right?
Yeah.
This is the total field, and you break it into components, ey
Oh,
and ex.
okay, yeah. Yeah, that makes sense.
And now I wrote it with respect to this angle because I know this is the angle made by it, subtended by it, and then I know this distance. That's why this becomes dey cos theta, and this becomes de sin theta. Does that clear your doubt?
Yeah, actually, I think it does. So from the, where do you get d squared plus x squared over, like to the power of 3 over 2?
Here,
From,
I
yeah.
have x squared plus d squared here, and I have x squared plus d squared here to the power 1 by 2. This is 1 by 2, right? If I
Yeah,
delete,
but where does the 3 over 2 come from, I think?
if you multiply them, then 1 by 2 in plus 1 is 3 by 2.
Oh, yeah, obviously.
D by 2 is 1. This is 1 by 2.
Yeah.
That's better.
Yeah, I think I'm good.
Okay, anybody else? Please type anything if you don't want to speak. Please. Yeah, please go ahead. You can open your mic or type. Typing is like a lengthy process, so that's why I can open the mic and speak. Just like regular class, the actual DGD session. That's how it's supposed to be supposed to happen. Yeah, we will wait for you, Randy. You can any one of you can ask me conceptual question as well. Like if you're not you have a midterm approaching and if you have some doubt that you've been bothered about, can we do the sphere question with sphere question with the shell 18? This one, Anthony. If you have a sphere and a hole inside it, I'm not getting it actually. Can you please be more specific? The homework question. Or I have to read the question for that. I have to read actually the question. I'm not getting the context of it. I'm very sorry for that.
So I found the integral that I was looking for. It's in,
Okay.
do you have the slide decks? Do you have access to his notes that he submits to us?
Yes.
It's the electric field of a uniformly charged disk in 2D.
Okay. So you want me to open his note?
Yes, please. I think it's too big to try and copy and paste into the text
Okay.
box. I don't think it would come out right.
I have to open bright space, right? That's correct, right?
Yes, yeah, it's in his PowerPoint of chapter 23.
Let me see. You can still see my screen, right?
Yes.
Okay. I'm logging in. That's your course, right? 11322.
Yes.
Yeah.
And
And lecture notes.
lecture notes, chapter
Which
23,
one? 3.
and I believe it's slide 13, if I haven't messed this up yet.
This one? Oh, this one.
This one, yeah.
Okay. Go ahead.
Um, so I'm not sure where, like, I think there's steps that he didn't include in the solving of this integral. I was wondering if you could just solve this, like the EX, from start to finish and just show me the steps because I'm really confused as to where that 2 comes from at the very end.
This 2.
Yeah, and I
This
don't know
one.
why it's 1 minus. I tried to solve the integral on
No,
my
this
own.
is 1 minus for the limit.
Yeah, once you sub the limit in. But I did that
Yes.
and I didn't get
You
this.
didn't. You didn't get it.
Yeah.
Okay. Okay. So you have an x outside as well, right?
Yes.
Okay.
Where
So
does that
uh,
go?
okay. Um. So this you're not sure how you got this, right? Dex.
Yeah.
First, this is your first doubt, right?
Yeah.
Okay. So it's actually same to this question. You have a theta component here, cos theta. I think I did that in my first DGD. Let me bring it up. GGD cos theta. Yeah, here. This is a kind of disk, not a disk, though this is a ring.
Okay.
But this is the cos theta component. Because of the symmetry, you have only cos theta component in the direction of the I cap.
Okay.
All the all the vertical components cancels out because of the symmetry. Then you have only horizontal component remains in the direction of I cap. That is your I axis or x axis. That's why you have cos theta, and you can write cos theta like this, right?
Okay.
And that's how you get this k qx a square plus x squared 3 by 2. I think this is how he gets it as well. See, x squared plus x squared 3 by
Okay.
2.
So I
Exactly
understand that,
same.
yeah. And then
and then this is dq. Dq is written as sigma dA. Sigma is the charge per unit surface length.
Mm-hmm.
Okay, then because you are finding this is a continuous surface, again I said that this is given in the problem. How to find, why I using integral? Because this is uniformly charged surface. uh, we have given sigma. Sigma is charge per unit area element. That means it's per every infinitesimal area element, it is uniformly charged. That's why I have to do the integral over all the points. That's why I have to use the integrals. And dA is written as 2 pi r, the strip of this area, 2 pi r into dr. So what is the circumference of a circle? 2 pi r, right?
Mm-hmm.
And to find the area, you multiply by the thickness of it, that's dr. So he gets 2 pi r sigma r dr. That's what he substitutes, and then it's just the integral.
Mm. Okay. So as far as the integrals go for the exams, will he expect us to have written all of what is on this page before inputting numbers to solve this question? Like
Like
for,
all these steps,
yeah,
I think yes, they all are necessary steps. Okay, again,
like I wouldn't be able just
this
to
is
skip to the end of the integral that's solved and input my numbers. Like I wouldn't be able just to start with ex equals 2 pi k e, like that part.
you have to tell like why, how you got dq.
Okay.
Then you have to tell how you get dex. Then you have to give this symmetry argument that just I told you about, and then you have to say that now this is this, and I'm doing integral over r, that r goes from 0 to capital R, the whole radius of the disk. You have to explicitly state that.
Okay.
You can skip this step, but I think it's good to show it because you won't make mistake yourself.
Right.
If you are not, like if you're a pro with integrals, then you can skip it. Yes,
Okay. Okay.
but personally, I wouldn't do that.
All right. That'd be,
And another question was, how did you get this?
yeah.
So you just apply the limits from R to. Should I show you?
Um,
Try it. You'll get it. You take one R common,
okay.
you'll get it. 1 minus x by r. And if it's not, you can explicitly leave it. You don't have to solve it till this point. Okay.
Okay.
In the exams or anywhere, you write this part, the one before,
Mhm.
and then you apply the limits and leave the question there. Like you apply x as r, then minus x equals to 0, then you leave it there. I'll write it
Okay.
to make it clear.
Thank you.
So let's say, let, let me see. It was x square plus r square 1 by 2 minus half, something like that,
Mm-hmm.
right? No, small r,
Yeah,
right?
that was a smaller.
Yeah, it was like this. Let me see. Yeah, perfect. So minus half. So in exam, you can leave it at this point, applying the upper limit and the lower limit. Did you get it?
Okay.
You can leave it at this point. You don't have to simplify further.
Okay.
That's the beauty of physics. So you don't have to explicitly. If you get the physics right, you did your job.
Okay. I think I just got
Does
lost
that
trying to
help?
simplify it. I think that's what happened. I was trying to bring it.
It's
Yeah. Okay. That makes sense to me. Thank you.
okay. Any other query? Anthony said something, but we still have to show them to call the test is a test. When a uniform charge sphere of density plus p with the spherical cavity inside. So you have, if the question is like this, you have a cavity and you have to find the electric field at this point. Okay, just type the question number to me. I'll go in on the website and check the question for you. If that is not bad, I can access your website. I have the authority. Somebody said it's a homework question, so just draw a round circle like this. And a dot in the middle. And that dot represents what? Oh, dot in the middle of a big circle. And that dot represents what? Okay, Anthony, I think I need to read the question again. You can type me, you can email me the question. I can solve it for you. It is complex for me. I'm not getting the context. I'm very sorry. I'm the kind of guy who had to read the question like continuous. So you, I'll type my email here. Uh, this is a conductor surface, and this is a charge at the center.
I sent it. She's.
Sorry,
I sent it to your email.
I can.
I sent the question to your
Not
email. It's
okay. Okay.
it's question
Okay.
35 of chapter 23.
It's in. It's in the book.
Yeah.
Oh, let me. I have the old book for you. Yeah,
Yeah.
I have the ninth edition. I don't have the 10th edition.
I'm not sure if it'll be in. No. I know for sure it's in the 10th edition. I'm not sure the ninth edition.
Solid sphere. Let me check the email. Any other question for the time being? Okay. Okay. Given a uniformly charged sphere of density rho with a spherical cavity, find E at any point inside cavity. Okay. Mm-hmm. So this this is kind of Faraday cage, right? You guys with me? You guys can see my screen?
Yeah.
Okay, perfect. Here. Again, it says in the question, okay? You have given a uniformly charged surface and that means you have given. Let me open one note. Okay, I get the question now. Thank you. But is it a homework problem? I cannot solve it then. I am stepping out of my bounds. Please don't play me here. The professor just explicitly said to me that you cannot solve homework problems. Homework. Okay, can anybody say something here? I'm not getting from your chat. Somebody says the solution is available. Somebody wants to see easier solution. Somebody says it is. Somebody says it isn't. I believe you guys. Just tell me.
Yeah, this one's not a hard question.
Okay, I believe that. So because somebody wrote that, that's why I wanted to confirm before. Okay, so you have to find. Let's say if you don't have the cavity, how you solve it? Let's solve it in steps. Okay. If you have a uniformly charged sphere, right, and you have to find the electric field at this point from the center. Are you with me? Hey, I'm still believe you're with me. Hey,
Sorry, what's beside the du at the E equals K?
dV, rho dV. That's a volume element because it's given a uniformly charged volume charge density.
Oh no, sorry, the symbol before the dv.
Rho.
Rho. Okay, thank you.
I'm just retyping it. That's 4 pi r square. Sloppy mistake. And rho can be written as. I hope you saw this somewhere when you're doing the practice. Everybody's with me for this? Still here? This is the sum of the field. I still don't get your question. Are you saying shut up to me? Can you please don't write like personal chats here? What does this integral represent? Yes, so this integral is here because you have uniformly charged and sphere with every element, every point element has a charge related to it. Then you have to take the effect of all charge elements. Thanks. And in your question, you have a cavity here, right? Then you subtract the contribution from the cavity. What's the radius of the cavity in the question? Is there any radius of the cavity inside? Or you just need to write in terms of A? Yeah, it is 4 upon 3 pi r cube. So why I pointed out that's how you can solve the question. You first assume there is no cavity, okay? Then you find due to every element the effect at point Q. Yeah, so that's okay. So now once you find due to every element, you just subtract the effect due to this element. Does that make sense? Physically it makes sense, right? Just tell me whether it physically it makes sense or not. Thank you. Now I have to see the question again. Okay, so you have to find it at the center. So actually I solved this for the electric field at point this, right? That means A equals to 0 in this question, what I solved here. Oh, I can't see your comments. Yeah, that means A equals to 0 at that point. That means it's not valid. Electric field is 0 at the center, according to this equation, right? That's called singularity at the center. You cannot solve. The Coulomb's law is not applicable there. You can't speak. I didn't mute you. Are you opening your mic? I'm waiting for you. Okay, let me see that. Yeah. You want me to confirm whether regarding how this solves it? You can see my screen right now. Okay, okay. There are two ways. The one I was telling you here. You can find the contribution of whole sphere at the center, and then subtract the contribution from this. That makes more sense. And that is, you have to do two integrals, one this one and the other one for the subtraction. You say this is a whole sphere and you will get the same question, same answer, but you just do have to do two integrals. And you say there's a charge at the center of it by r square, and charge is given as rho dV. Okay, now it will be 4 pi r square dr. This is a square, right? And this you can do. Okay, so what a square is the distance from the cavity center to the point you are trying to find your electric field, and you assume this is a uniformly charged. That's why you subtract it, though it doesn't contain any charge because it's a hollow surface. But you assume, because you're subtracting from the total, you assume that it's an hollow, and you subtract it to get the answer. Did you get that? And you have another way. I sure I can match your answer with the way I'm doing. And this is, somebody solved it. Is this your professor? No. Okay, it doesn't matter who solved it. Who doesn't? It doesn't matter. So again, it he says that, you see there is a negative r, a negative rho. This again means subtracting. That's what I was telling you. If you see there is a negative sign here, yes. So they actually broke it in components E plus and E minus. So the total electric field, they calling due to plus component of rho, plus rho, and negative rho, right? Continue on it. Makes sense. Okay. So this is the thing. I was not getting the problem. The point P, they're finding the electric field at this point, at the point above the spherical shell, here, at this point inside the spherical shell, at point P. You can see there's a point P marked there, and you are just writing R1 minus R2 as A cap. That's it. It's a very simple problem actually. You're breaking that into components, and what I'm writing is just writing the big part of it. Yes, this no, both are the same methods. I'm also subtracting it. If you can see, it's just they're writing electric field in short form and using the vectors. Uh, if you do the integral, you'll get the same answers. Yes, this type of question you can expect to see on exam. Yes, I deliberately think that this is not very difficult, because let me tell you what they did. They have, as I told you. Okay, if you're done chatting, then can I speak? Because I have to wait for your messages. So here you don't have to freak out if you see the problem. Problem looks complex. There is a cavity. Just remember what I explained here. You have a cavity, then you first in the first step, what you do is you find the effect at point P. You find the effect at point P due to whole sphere. You assume there is no cavity inside. Is somebody still listening? I mean, if you all get it, then I can move on. Yeah, I think everybody get it. Then you get it how I solved the problem, how I knew how to solve it. Okay, just concluding it. You assume there is no cavity there. You do the integral. You find the electric field. Then you subtract it. That's how physically it makes sense. This is the question. What he sent it to me. So physically, what you do if you have a hollow somewhere, you take the summation effect due to hole, and then you subtract it. That's what I did, and that's what they are doing. They're just writing short forms to get rho r 1 cap by 3 epsilon naught. You still have to do the integral, right? People with me? If you still have to do the integral, if you already know by practice that electric field inside can be written at rho r cap by 3 epsilon naught, then it's good to go. Otherwise, you do the integral. The whole point is that there is a subtraction there. Perfect. I think, let's see, somebody's typing. Okay, I think that's it for today. I I'll stop the session. I thought we I hope you got it. You got something out of it.
Thank you so much. This was very helpful. Found it very helpful. Thank
Yeah,
you.
thank
Thank
you.
you. That was my aim.
Big time
I'm gonna
appreciate
stop the
that.
recording. It's okay. I'm always there for you guys. Okay, even after the course, if you have any query, you can still type me, even if I'm not your TA. I just like if I can explain some physics to some people, if I can.
Thank you.
Uh, Also, for the Friday session, let me just stop the recording first. Thank you very much. Then I'll chat.